Good morning, and welcome to our latest UCS Tech Talk. The Tech Talk that we're going to have today is going to talk about our C-Series standalone servers. We're going to teach your old server some new tricks. I want to go ahead and introduce the panel. My name is Eric Williams. I'm a technical marketing engineer for Cisco, and I'll be the moderator today. Start from left to right, so Jeff Foster.
Hi, my name is Jeff Foster. I'm also a technical marketing engineer here for Cisco.
And Johnny at Bright.
Hi, I'm Johnny from Bright Computing. I work as a software developer at Bright Computing.
And Steve.
And I'm Steve McQuerry. I'm also a technical marketing engineer with Cisco.
Well, great. I just want to start off with a few questions. I'll start with you, Jeff. I'd like to get a little bit of an overview of what C-Series is, what our C-Series servers are, and what kind of servers that we have, just for folks that may not be too familiar with the UCS standalone rack mount servers.
Sure. Our C-Series servers are a portfolio of many rack mount industry standard servers. We've got a variety of servers in the portfolio, all the way from our entry-level C22, C24, to our performance-focused C220, C240, and C420, all the way up to the C260M2 and the C460M2. The platforms I mentioned earlier were M3s, but this is the current portfolio of C-Series servers that we have.
I know there's a couple ways that you can use C-Series servers. You can use them integrated into UCS Manager and use them standalone, so not integrated into UCS Manager. Can you compare and contrast the two different use cases?
Yeah. So in integrated mode, we turn control over to UCS Manager, which is running in the fabric interconnects, and at that point, our rack mount servers become peers to blades, where they're a compute vehicle, and the service profiles are applied, or the identity of the system is applied by UCS Manager. The other operational mode that you mentioned is standalone mode, where each of these C-Series servers are run as an independent system, and we have a management controller that will allow customers to manage each of these platforms as an individual entity. So I think today we're going to talk about more of the standalone mode of operation.
So what are some typical use cases that you see people using the C-Series servers in standalone mode compared to using it in UCSM?
So in standalone mode, we often see customers using this at branch offices, remote offices. We see quite a bit of retail usage. Any environment where a customer wants to run their enterprise servers but don't have a need for a large number of servers, or they may need just one or two platforms. Customers that want the manageability to be able to manage independently every system as an autonomous unit is another use case as well. But traditionally it's in branch office, remote office type environments.
That's great. So I'd like to get a little bit of let's drill down a little bit into the Cisco Integrated Management Controller. So Steve, I'd like to understand a little bit about the Cisco IMC. What's its purpose in the actual servers that it manages?
Sure. So the Cisco IMC, or Integrated Management Controller, is essentially a baseboard management controller. So most major server vendors nowadays have some type of out-of-band or lights-out management. On the server are reported to the Integrated Management Controller, as well as a configuration task, the ability to configure things like the boot order, BIOS configuration, lots of different components within the server. KVM into the server, do power resets, basically anything you would do, that you would want to do to the server. Most of those functions are handled through the integrated management controller. And incidentally, the fault reporting is kind of unique in the sense that we don't require an agent. The IMC itself can be part of the SNMP environment, and that not too long ago.
Oh, great. So what other types of actions can you do? I mean, you can do a lot of the BIOS config, boot order. Can you do firmware upgrades, and can you mount vMedia through that IMC and configure your storage?
Absolutely. So those are some of the unique features to the IMC itself, right? We do have the ability to configure the BIOS settings. As I mentioned before, we can configure the boot order, things like that. But one of the things we've recently added is the ability to configure the storage itself. So, and by this I mean configure the volumes on the RAID controller without using a third-party utility or without having to entering the option ROM of the controller itself.
So it's doing it through an out-of-band configuration. So it's doing it fully out-of-band. You don't have to go into the BIOS whatsoever.
Exactly. It is a it is completely out of band and not dependent on anything or any third-party utilities. It's part of the system itself.
So what interfaces does SIMC support for monitoring and configuration and such today?
So from a configuration standpoint, SIMC supports a web UI, right? So we can go in through a web UI or a command line interface for customers who want to write expect scripts or interact with the command line interface. But one of the most unique features is, much like UCSM itself, is an XML API. So we have the ability for customers to actually go through the XML API and perform most of the management and configuration features that we can do within the command line or the web UI itself. Ultimately, the goal is to be 100% from what we can do with the command line or the web UI within the XML API as well. And this provides a real benefit for customers who may not want to have a UCSM infrastructure but still has a large amount of servers that they want to manage. In the past, when customers did this, they typically used tools like IPMI or some other vendor tools. IPMI is a good tool, but a lot of times, outside of the standards, vendors have to implement things that are very specific to a platform. And so as you upgrade from one generation to another generation, that platform and those commands may change. It's also a lot of raw hexadecimal, a lot of raw returns. It's not very, we'll call it user. The goal of the XML API across our platforms is to be consistent. So it wouldn't matter if you were on the low-end servers like Jeff talked about, the C22, C24, or on the higher-end EX platforms, the C460 or C260. You would have the ability to actually, build scripts, build configuration parameters to manage these servers. And as you went from third generation to fourth generation to fifth generation, this should be consistent across your platform, so you're not constantly respinning your management tools within your data center.
Oh, great. So I know tell me a little bit more about what technical things we're planning to cover today. I know we have a kind of funny name to this particular session, teaching your old server some new tricks. I know it sounds catchy, but what's some of the meat that we're planning to cover? And if we can start to get into some of that, those new tricks that we can do with the newer versions of SIMC.
Absolutely. So some of the things that we've added that we think are real benefits to our customers are, one, the ability to manage the hard drives through the SIMC. So that's one of the new tricks we want to talk about is, typically you're going through web BIOS or the option ROM on your RAID controller when you configure it for the first time. So, many vendors use LSI, as do we do. Other vendors may have a different type of controller, but regardless of what that is, it requires some downtime for the server on initial configuration, meaning, or shouldn't say downtime, some interaction with the boot of the server for an initial configuration. And then if you want to modify or manage those drives after the server's operational, you typically have to load some type of utility to do that. So what we've tried to do is separate what the administrator or the infrastructure administrator's responsibilities are from that of the server admin. Also separating the ability to, or the need to qualify additional, components, whether they're agents or actual, software components that have to be added in order to do real-time management and monitoring of the systems. Another one is, how we mount virtual media. So most servers today, we're starting to see people not want optical drives on the servers. There's a lot of the concept of not going into the data center to manage the servers. So through remote KVM, we can mount media, but that's not always the best way to do it, especially if that remote server is thousands of miles away from you, and then you're trying to share media on the workstation that you're connected to that's, just a very latent device and low bandwidth connectivity, so it can be cumbersome. And then,
so it really allows you to have the lights out management capability in your data center with this you don't have to really ever touch the physical system unless something goes wrong.
Absolutely, and that's the goal, right? Is not to be touching the server, plugging things into the server, popping CDs into the server, etc. Right? To be able to manage it and to be able to manage it effectively, so that you're not dealing with the fact that hey, I'm 3,000 miles away from some of the servers in my lab, right? I don't want to host an ISO locally, when I'm at my home office and try to load that on a server that's 3,000 miles away from me. Some of the other things that we're going to talk about is, how we've extended some of these features to be able to do some firmware upgrades and firmware management. You mentioned the ability to do firmware upgrades and management within the SIMC, and that does exist. But what we like to do is keep our customers on a common firmware build. When we qualify for an operating system, we qualify across the board on specific firmware builds. So we have a tool we call the host update or host upgrade utility, which actually updates all of the firmware components in the system as one bundle. And this is an ISO. We typically mount virtual media, but it does require some interactivity. So one of the things that we've expanded with these new features is the ability to do this non-interactively. And then, of course, some of the other things from a new trick perspective is the XML API I mentioned earlier as well.
Oh, great. I think it would be great to start getting into some of the demos that we've got prepared to start showing some of the capability to actually how to manage it compared to the old way to the new way. I think one we have prepared to talk about is showing some configuring things through the SIMC that you'd have to normally do through an option ROM.
Absolutely. So let's kind of start and talk about this. Sorry, two things at once. My brain stopped working there for a minute. Talk about the ability to configure the hard drives from the SIMC. And what I want to start is with the old trick, right? Let's look at the way we would normally do it, and then let's contrast that to the way that we'll do it, within the SIMC itself. Then I want to show you a little bit of a neat feature of being able to do some things to the drives on a live system without really touching anything in the operating system itself. So we'll start here with the old trick, right? And this is a typical server, factory fresh, nothing configured. And you notice as we boot here, we have no virtual drives on the adapter, no virtual drives handled by BIOS, which means, this thing doesn't see anything from a configuration standpoint. So as it comes up, we're going to get an option ROM option, a little redundant there, but the ability to go into the card itself and load some software to manage the card. So as it was booting, I pressed Control H here. It brought up what we call Web BIOS. Web BIOS is the option ROM that runs on the LSI adapter. So now we go into the Web BIOS and we select, the card that we have in here. This will be the only RAID card in the system. And we go through and start configuring the virtual drive. So I'll do a simple configuration wizard here with a new configuration, and then step through the process where it says, you're going to clear everything. Sure, I want to do that. I'm going to do a manual configuration. And then the first thing I'm going to do is select the drives that I want to deal with. So I'm going to select these two SATA drives here, and I'm going to add those to the array. Then after I add them to the array, I have to accept the virtual drive group. Then after I accept the virtual drive group, I go to the next step, which is where I add that to the span. Essentially, if I'm going to span multiple drives, do something fancy. Here I'm not. I select my RAID level, any configuration from a stripe, access policy, drive cache, tell it how big I want the virtual drive to be. If I update the size, it picks the maximum, and then click on through. Once I get to this, I don't want to create any more virtual drives. I accept the virtual drive that I have, save the configuration into the system, and allow the controller to initialize the drive. Now, the one other thing I'm going to have to do here is if I want this to be a boot drive, I'm going to have to set it as a boot drive. And then I can exit out of the utility, right, and reset my system. Now, we see there's a virtual drive created here. It's optimal. And when we reboot the system, what we expect to see as the option ROM loads, we expect to see that we've created a virtual drive in this system and that that virtual drive is now created by BIOS. So we see the RAID 1, we see it's found on the adapter, we see it's presented by BIOS. Now, to contrast this, what we want to do is look at what we can do in the Cisco Integrated Management Controller. So as I mentioned before, we have 3 ways of accessing this: the web UI, the command line interface, or the XML API. So here we're going through the web UI where I've put in the IP address assigned to the SIMC, and I'm going to log in with my username and password. And then once I log in, I've got a variety of tabs here. We're going to select the storage tab. And the first thing you'll notice here is that it tells us the storage card information is basically, you know, cache data. So the last time the server was up, this is what we loaded into the SIMC, or the Cisco Integrated Management Controller, and this data is essentially cached and outdated. If the card's not up, the server's not up, we can't communicate with the card, we can't configure the card, so we're going to have to go and turn the server on. So we'll click the power up here. I've edited the video a little bit so we don't have to wait as long for all of the power up. And now we can go and look at actual information. So we see that we have the 4 drives in here. They're all unconfigured at this point. They're good. We can look at our virtual drive tab, see that there are no virtual drives. So we go to our
you basically have cleared the configuration from the last time. So
absolutely. Yeah. Before I started this, I cleared everything out.
Okay.
So we go to the create virtual drive from unused physical drives, and it brings up this window. And the first thing we would want to do is select our RAID level. So we're going to select a RAID 1, and we're going to select 2 drives here. Now, one thing you'll notice, the arrow keys in the middle here, the add 2 groups, as I've selected 1 drive, it doesn't actually let me add that to the drive group because 1 drive would not be a valid RAID 1 configuration. Once I select that 2nd drive, then it lets me add it to the drive group because it would be a valid RAID 1 configuration.
So it would do that for any other type of RAID configuration as well. So if you're doing RAID 5, you have to specify the minimum number of disks to support RAID 5 or other types of RAID, correct?
Absolutely, absolutely. And what's really interesting is, let's say you're doing RAID 10, right? For RAID 10, you would need at least 2 RAID 1 drive groups. If you added the 2nd RAID 1 drive group, the little Create Virtual Drive button down in the bottom right-hand corner would be grayed out until you met the appropriate number of drive groups. The same would be true for a RAID 5.0 or a RAID 6.0, depending on what the controller can actually handle. So we have the ability here to name this virtual drive. You know, the system's going to pre-populate. You know, this is a RAID 1 with drives 1 and 2, but sometimes we want to give it a meaningful name. So when we go look in the virtual drive tab, you know, we can actually see something that means something to me. All right, so I'm going to call this my boot drive. I have the same options: stripe size, write policy, read ahead policy, cache I/O, and of course I can size this drive. And by default, we choose the maximum available size. This can be edited if you wanted to create, you know, smaller virtual drives within a virtual drive group itself. So after we select that, we create the virtual drive, and we're done. At this point, you know, we can go see the virtual drive in the system. It's good. We do need to set it as a boot device. It was initialized once we created it. So we'll set it as a boot, and we'll boot the system back up, and we see the same thing, the exact same configuration we had when we did it with Web BIOS.
So what's the actual interface that the SIMC communicates to the LSI RAID card to make this configuration changes?
So it's actually across an I2C bus within the system. So an I2C bus is an internal communications bus between the cards and the system itself. So we are communicating, you know, with daemons that are running on the SIMC itself, across that bus to communicate the card. So as long as the card's up, we can communicate with it to provide new configuration parameters, to check status. And as I mentioned before, we get real-time reporting information from that card. So if that virtual drive were to be degraded, say one of the drives failed, we would get notifications as we pulled that card across the I2C bus, which is not anything where we're using data. It's not the PCIe bus. It's a separate management bus. And that real-time data would then be sent to the SIMC fault engine and could then be reported out via SNMP to a trap receiver.
Now, you're showing how you can configure something probably on a new server. What if you have an existing server that you want to add a volume or something to?
So that's a great question, Eric. If you look at what we've got here, this is the actual server that I created the volume on earlier. I went ahead and installed Windows on it. And we see here our disk 0. That C drive is our boot drive that we configured earlier. It's the RAID 1 configuration. And what I want to do is actually add, another volume. Actually, I'm going to add a couple of volumes to this system here. So this system is up and running at this point, right? If I wanted to go back to Web BIOS, I'm going to have to reboot the system to get into Web BIOS, which means downtime. If I wanted to load Mega RAID Storage Manager or Mega CLI, then I'm going to have to load another application on the operating system, which could take some qualification, and it's going to involve, possibly the server admins as opposed to the infrastructure admins. So the nice thing about having this in SIMC is the infrastructure admin could go pop in a couple of more drives. My system already had a couple of drives in it. They could then go to SIMC and create a virtual drive from the unused physical devices. And adding the new drives, hot spare, they'll show up here as well. So I'm going to create a data store here. Call this one data store. And I'm not going to make it full size. I'm actually going to make this one, a partial virtual drive of the actual drive group itself. Now, we switch back to Windows, and there was a little bit of a clip in time here, but it's not much. I mean, this is almost real time, as in it's going to show up within about 2 seconds of creating the drive. We now see this new virtual drive in the live operating system. All we have to do is have the server admin go in and create a new volume and format the drive through Windows, and it becomes available to the operating system. Excuse me. We go to the virtual drive tab, we see that it's there. Now, one of the reasons that I chose to create, a virtual drive without using the full drive size is, for some reason I needed another virtual drive out of that particular drive group, whatever the case may be. We also see the action of create a virtual drive from an existing virtual drive group. If there's space left on that drive group, I can create another virtual volume. So I'm going to go down to that data store volume here. And the drive space that's left, and it tells me the largest available drive space, I'm going to create another virtual drive within the physical drive group that was that RAID 0 group I created earlier. We go back to Windows, and there it is. Just go in and format the drive, and it's available for use. So that's pretty much the new trick from a drive configuration standpoint. Any questions?
No, it's a great start. I think it'd be great to transition over to how, kind of the old trick of how you would, map vMedia on a KVM versus how we can do it today with a traditional, with what we can do with a SIMC mounted vMedia.
Absolutely. So, as I mentioned before, a lot of our servers nowadays, we don't, put optical drives on them. There's that idea of not going into the data center, not having to carry the drive trays around. So virtual media has been around, in UCSM and within our C-Series since the beginning, right? And to open a virtual media session, we essentially go into SIMC, and we kick the vMedia session open. Now, before we do that, though, I do want to go through my system here. And since I'm, wanting to mount a CD-DVD-ROM, CD-ROM DVD here, I want to actually change my boot order because my system still has Windows on it, so I don't want it to boot Windows. I'm going to go into BIOS, and this kind of shows us some of the features here where I can change the boot order of the system. I'm just going to move the CD-ROM up, and the next time I boot the system, that boot order will change. So the reason I did that is because when I mount virtual media, that's presented to the system as a CD-ROM. So here we've opened up the KVM console. and I'm going to go to the Virtual Media tab. And here I'm going to add an image. So when I add this image, this ISO that I'm selecting here, is actually on my workstation that I'm launching this KVM from. So I'm hosting it from my specific workstation itself. And whatever network connectivity I have back to the Cmc itself, that's what I have to deal with from a mounting, reading, writing, delivering that data to the system. So I'm going to pick our host update utility here, and I'm going to boot the system up. Now, again, my lab is 2,000 miles away from my home, so I typically work from home a lot. And when I do, sometimes my network connection's not great. Sometimes, I may decide I need to shut my laptop and go do something. And when that happens, I lose the KVM connection. So we can see here that we're reading bytes. That's showing that we're reading off of our system, sending it to the local machine. We see the local machine booting it up here. And I'm going to close this KVM out here as I'm loading system stuff from my machine. And then I'm going to bring it back up, and we're going to see what happens. All right, so this is what would happen if I were to lose my network connection, shut my media down. Basically, the system errored out because it couldn't read that drive anymore. It'd be like walking up to a computer with an optical drive in it and punching the button and pulling the CD-ROM out of it.
So you're basically your KVM session's your single point of failure on this. If it fails for whatever reason, or whatever you're doing, if you're doing a firmware update or installing an operating system with that KVM mapped vMedia, it's basically, since it's passing all the traffic, that's your single point of failure for your vMedia.
Absolutely, that's absolutely right. And also, again, consider that if this is a remote data center, right, and you're a long way away from it, you're limited by the bandwidth and the latency between you and that data center. So it can be very painful to try to load a full operating system, across a slow speed and low latency, high latency link. Yeah, we wish it were low latency. So the new way we do this is if we go to our Remote Presence tab, we have a Virtual Media tab under there, and you see now that we have something called a Cmc mapped vMedia. So what this is doing is allowing us to map that ISO directly to the Cmc across the local network connection, not using the KVM and my remote machine to grab that data, but letting the Cmc interact with that vMedia. Hopefully, local to the data center, right? Ideally on a small CIFS or NFS share or even web server share within that data center where you've got these ISOs mounted.
So what you're basically saying is the Cmc at this point is proxying the mounting, not your KVM session. It's basically the data path. Instead of going from wherever your ISO is to KVM to the Cmc, now we're taking out that KVM session out of the loop, and it's going to be your ISO directly mounted to your Cmc.
Absolutely, that's exactly the way it works. And the Cmc is, running the protocol to communicate directly with that ISO. So, we'll see here in a minute. But if I stop my laptop, I shut it down, whatever, this is going to continue to be available to the Cmc and therefore to the server itself. So when we go in to map this vMedia, right, it pops up the window, so we can give it a volume name. I'm going to call this one HUU, and we can pick a mount type. So the mount types that we support are CIFS, NFS, and HTTP or HTTPS. So I'm going to pick CIFS because I've got a CIFS share locally here. And then it asks me for the remote share. So, if you're like me, Eric, you forget things a lot. You've got a lot going on. I don't know about you, but I've got a lot going on in your head, a lot of stuff happening. And you don't always remember what the remote share is supposed to look like or what the syntax is. So we've always got these nice little buttons in here. I've got the little help utility button here. So I'm going to pop that up, and I'm going to go down and say, what's my remote share field supposed to look like? So since this is CIFS, it actually follows a standard format, // the server IP or domain name if you've got DNS configured on the Cmc itself, and then the share that we want to go to. So I'll enter my remote share information here. And then it's going to want to know the name of the remote file. So I'm just going to go to this remote share here, pick the actual file name, and instead of typing all this in, I'm just going to copy and paste. So I'm going to select the file name here, just get a copy of what the file name is, and then go paste it back into the window because I don't want to remember what all to type there. The key thing I have to remember is I do have to put the .iso extension. If I don't, the system's going to tell me that. And then in this case, I'm going to add a username and password. Depending if there are mount options, those are listed in the help as well. If you're doing something special on your CIF server or your NFS server where you need specific mount options, those are available. But here, I'm not doing anything other than, just going to do local authentication. Now, the system's going to go through a mapping status, and it's going to tell us up here it's in progress. If there were a failure, it would tell me that it failed. In this case, it's successful. So this is now available to the system. So I'm going to go back and power cycle the server. And notice I don't have a KVM launched at this point. All right, I just power cycled the server without the KVM, and the CD/DVD is still in that particular boot order. Now notice that we've got the KVM map DVD and the SIMC map DVD. Since there's no KVM map DVD in the second level boot order, it's going to pick up the SIMC map DVD if that exists. If it didn't exist, the system was going to boot into Windows because the hard drive with my Windows build is next in the boot order. So we'll go up here and launch the KVM, and we see that it's actually in the process of loading. So without having that virtual media, without having anything added, the system had that in the boot order. It went ahead and started loading my host upgrade utility. So we're going to close this like I did the last time. I'm going to close the KVM out, and then I'm going to open it back up. And I opened it back up a little bit later, but we see that it went ahead and loaded the host upgrade utility without me having the KVM attached. I didn't get that error message. So now I have the ability, to start that, go do something else, or start it on a bunch of servers and go do something else. And then once it's up, I can go in and interact with the system itself. And what's really interesting is that kind of dovetails very well into some of the programmatic stuff that Jeff's going to talk about, because, here I would have to mount this ISO, go back to the system, and then select what firmware to update, or if I wanted to update all of it. While mounting the media, virtually is a nice feature, if I still have to interact with everything, it's still time on my part to go out and interact. So, part of the things that are really nice about the programmatic infrastructure is we can do some of this stuff without having to manually interact with the system.
That's a great segue to talk to Jeff a little bit and get him involved. What Steve was mentioning is awesome, and I would like to take a little bit more time to explore this some more. He was mentioning the firmware updates, and I know you published some firmware-related content on our Cisco UCS Communities page. Can you share a little bit about how vMedia is going to impact our firmware updates and with scripting and whatnot?
Yeah, absolutely. So what Steve had shared is really the foundational elements that have enabled us to update all system firmware non-interactively. So on the ISO that Steve had just booted, we can update the SIMC firmware, the system BIOS, RAID controller firmware, and all of the other Cisco sold devices, so the PCI cards, etc. So we have that firmware package that we can now mount through the SIMC. Now, taking that to the next step, we can programmatically execute a job through the XML API that will non-interactively deploy that firmware. And I do have a video here that highlights, it takes what the example Steve just provided around SIMC mounted vMedia and takes that to the next level where we're actually programmatically deploying that firmware to the target. So these, you had mentioned communities. These videos, along with a getting started guide, are available on communities as well as with the utilities that I'm going to share with you in the second half. We have a Windows-based utility as well as a Python-based utility.
And if people aren't familiar with communities, it's communities.cisco.com/UCS. That's the website you can go to get more information.
Exactly, and this is available under C-Series. So in the old trick, what we would have to do, in this case, we are logging into the SIMC. You can see here that we're running 151A. I decided to take actually the approach that Steve had mentioned as his old trick as well. I'm going to launch the KVM window. And this could just as easily be done using SIMC-mounted vMedia or SIMC map vMedia. and I'm going to map that ISO. So in this case, we're going to go ahead and map an updated firmware ISO. And as we boot into this ISO, we're going to have to make all of the selections manually. So it requires that whether we map via the KVM or we map via the SIMC, you've got to be there to make the selections, which, to Steve's point, adds time, adds effort. Depending on how you have the device mapped, it may not be the most efficient way of loading firmware. So in this case, I can select each individual component, or because I want to make sure that I have a good, valid firmware recipe, I'm going to update all. And this video has been sped up a bit, and there we have it. All you have to do is select update all, and you will get the firmware image, but you have to go through, make your selections, and execute that there at the console through the KVM.
So that's the old trick, and so that looks like a lot of work that I'd have to be able to do. What if I want to do this across a lot of different systems? What's the best way to be able to manage and update 5 or 10 of my C-Series servers at once?
And that's exactly where what we were trying to solve with this new trick is the ability to programmatically push firmware out to a large number of systems. And the enabler to that is the XML API for the SIMC. And we have a couple of utilities that are available. I'm going to use the Microsoft utility in this case. So I'm going to open the Microsoft utility, and I'm going to enter the information for the target SIMC, the share where I've got the ISO loaded. So we're going to use SIMC map vmedia. I'm going to point to the location of the ISO and specify the ISO. And I can do this for a large number of systems, and I can save this configuration. So here I'm just going to, again, select all components for all of my systems. I can save this, so if I want to come back to it at some later point in time and update these systems again, I can do that.
So this is using the same scriptable vmedia that Steve was using before when he was doing the manual process. It's basically telling that this utility to map that particular vmedia from the CIF share or HTTP or an NFS share directly, but also talking to the API to tell it what actual updates, so you can be fully hands-off and not have to go to the KVM session for each of these systems and tell it what to update, correct?
That's absolutely correct. So you can, in the old days, you used to hear set it and forget it, and that really is the case here. You can select the ISO, you can select the systems and what elements you want to update on the system, and then it's just a matter of using that XML API and SIMC mounted vmedia, and no longer do you have to babysit the console or the KVM window. In fact, you can see here, I've paused this, but the screen will actually go out and query the system. So we've got some systems here, because I have different platform types, that are already in the verification process, because I did update and specify that I wanted to verify the update. So at the end of the firmware update, I will get a status for each one of these. In this case, we got a verify complete for all of the target systems that we were going to update. And if I select on any individual system, I can see the current version as well as the updated version and the status, the verification status for each update. And again, these utilities, Eric, as you'd mentioned, are on communities, communities.cisco.com/UCS, and we do have a Windows and a Python utility available.
Well, this is great. Do our customers need to be an XML expert to take advantage of this?
Absolutely not. So we have the utilities already pre-baked, and for customers that want to leverage a utility, they can download these from communities, or they can certainly take advantage of the XML API itself and exploit the XML API to be able to trigger a firmware update on one or more systems.
I think we've got time for one more example about how you can teach your system some new tricks. You've talked about the XML API a little bit when we did the HUNI example, and it seems like it's something we should be talking about more. What are some other things that people should know about our API, and what are things that they can do with it that you can't do with other vendors' tools and servers?
So the XML API gives you a programmatic window into the system, and I actually have a system up here live that we can look at the XML API. So we have a model browser for the XML API available. I have a SIMC here, and if I add visore.html, I'm going to run a query here for fault inst, and this will give me the output of any faults that I have on the system. So from our talk last week, we leveraged the fault engine, and we're just running a query against this fault engine to understand exactly which faults may or may not be present on this particular system.
So this is the same thing that's available on UCS Manager that allows you to peruse the data store that we have in UCSM. It's basically doing the same thing here for a rack mount server, correct?
That's exactly right. So we're leveraging a very similar, in fact, the API for our standalone C-Series was inspired by the XML API for UCS Manager. And so a lot of the same methods, the same classes are available across both systems. In this case, I have no objects found, so there are no faults. Lucky for me, though, I do have an intelligent PDU that I can go ahead and I want to turn off one of these power cords, and let's see if I'm still logged in. I'm not. So what I'm going to do here is I'm going to turn off this power connector. I'll give it a second. And I'm going to rerun the query here. And while this query is rerunning, I do want to just quickly show a science project that we've done internally to highlight the benefits of the XML API. So we wanted to go out and look at, highlight the capabilities, highlight the benefits of the XML API. So we developed just a quick science project internally that we use to manage our systems. So you can see we've got pretty diagrams here, but across the top we have a menu system that will allow us to list the system, so list the SIMCs, inventory and faults. So if I want to get a hardware summary of all of our systems, I'll log in here. I can do that. And on the back end, this is all running and communicating with the client systems via the XML API. We're using Ruby and PHP in this particular tool. But you can see here that these are this is information that is pulled programmatically from the XML API to do things like inventory. It will show current fault status for all of our systems. So if I look at all of our systems, we put in a little bit of logic here. So we have a filter capability. We have OS deployment, whereby we can use SIMC-mounted vMedia, mount an ISO, and then power cycle the system using the XML API, and deploy an operating system, either Linux or Windows, and then the system will send a message back to this particular server and let it know that it's done, at which time we can reset the boot order and power cycle the server again.
So this is really we developed this as like you said, a science project to really show what is possible and truly stress kind of before we released our XML API on C-Series. Internally, we just wanted to make sure that we could really manage it at a pretty good size scale, correct?
That's exactly right. And we can do things. So we talked a little bit about non-interactive firmware updates. So one of the things that we've embedded here is the ability to update firmware for multiple platforms concurrently. And we're using the XML APIs the same way we're using it in the utility. And we've got all of this available in our XML API Programmers Guide. So what I'm going to do here is I'm actually going to update firmware from a newer version to an older version. And that's how easy it is. So
so basically that's doing the same thing as the utility you were showing before, but it's something we just we wrote ourselves to be able to to drive the HEU non-interactive utility and the scriptable media to mount that system or mount the ISO to update that firmware with the system.
That's exactly right. So it's it's all programmatic XML API. It's very well documented, and for customers who do have experience with UCS Manager, it is very consistent with the API from UCS Manager. Now, if I want to go in, we have a nice UI here that is taking information from that fault inst query, which we were running just a moment ago on one of our platforms. We've captured that detail here in this interface, and all we're doing is sending out the fault inst query. And you can see here, this is the system where I just pulled the power of one of the power leads. It initially had no faults, and now you can see we have two faults. One for a PSU status, so PSU, the power supply 1 has lost its input, and we've lost redundancy. So not only do we have the interface, but we also have the model browser in Visore that will allow you to browse the model, and we also have a very good document out on Cisco Communities that will help you. I believe we have almost 100 or over 100 samples that you can pick up today. In fact, every sample that we, every method that we used, we included in the document as we were creating this internal tool. So anything that wasn't there, and there were just one or two specific queries that we had that weren't included as examples, we made sure to include those in the document. So you could use that document to recreate something like our homebrew project here.
And basically, this is the same interface that our integrations that we developed, like System Center Operations Manager, Orchestrator, and PowerShell libraries, UCS Power Tool for IMC, are going to be using as well. And all of those are either in beta and going to be moving to being GA and available either on Cisco.com or our communities website for UCS integration, which is Cisco or communities.cisco.com/UCS integrations.
Yep, that's exactly right.
Well, let's segue over to talking to Johnny at Bright. I'm glad I'm sorry I had to wait a little bit of time to start talking to you, but I wanted I know that you guys have been doing some really interesting integrations at Bright with our C-Series XML API, and I'd like to first ask you, for those who aren't familiar, who is Bright and what do you guys do in the computing marketplace, and start off with a bit of an overview of who Bright is and what you guys are up to.
Hi, I'm Johnny, and I'm one of the developers at Bright Computing. So at Bright Computing, we developed a cluster management solution that's called the Bright Cluster Manager, and we support it, and it's already being used at several large supercomputers. So it's in short, it's a cluster management solution for managing all kinds of clusters, server farms, including HPCs, storage clusters, database clusters, and Bright Cluster Manager also provides you the ability to manage your clusters in the cloud, like the Amazon EC2. So
I know at supercomputing, like the supercomputing conference in 2013, you guys demoed some really new integration that you have been doing with Cisco UCS C-Series servers leveraging your API. Can you give a brief overview of, one, what you guys did to integrate, what the, and what the time it took, and issues you had, or what have you with doing integrations?
Yeah, so our Bright's partnership with Cisco's the main goal is to simplify the deployment of Cisco UCS based clusters by minimizing the manual steps that need to be performed while deploying a cluster. So the main targets were just setting recommended BIOS settings out of the box, being able to configure your US NIC profiles and everything just in one big setting, and then don't worry about it. So our main way of achieving this is obviously through the XML API that the SIMC provides us. So this is basically, right now we have done this only for the C-Series clusters and standalone mode. So the main way we achieve this is through the XML API. So I can show you some.
Did you guys write your own integration, or did you use one of Cisco's SDKs?
No, so we develop everything from scratch ourselves. So because we already have the cluster management part of our software, which already exists, and so we just needed to just fill in the remaining parts so that we can just nicely interface with the UCS. So we just wrote everything from scratch ourselves.
Did you do that in Python, or did you do it in Java?
So it's basically a lot of the parsing. So basically, all that you need is basically a decent XML parser to make use of the XML API. So a lot of the parsing is done in C++, and some of the backend communication is done through the Python, because we also have a Python binding for the cluster manager itself. So it's basically C++ and Python.
Yeah, I think it'd be great to transition to show what you guys have done with your cluster management software and managing the standalone rack servers today.
Yeah, so I'm just going to show you share a screen of our cluster management GUI. So this is so you can see it now. So this is our cluster management GUI. So when you install a Bright Cluster Manager head node, typically that's the first step in deploying a Bright cluster. So you install a Bright head node and you just fire up the GUI and then configure all your things, all your settings. So here you can see is that the Bright Cluster Manager has already detected that this is a UCS machine. So otherwise it doesn't show this UCS tab here. Here you can see that all these values or BIOS tokens, VIC adapter settings, and everything are automatically populated using the XML API. So we have a kind of one-to-one translation and mapping mechanism directly with the XML API and also the schema.
So you're basically getting all the inventory directly from the C-Series server and populating it here as well as the state of the server if there's any issues or faults.
Yeah, exactly, everything. So even all the status information, everything is being populated by obtaining it from the XML API. So there's also one more thing. Yeah, so this is populating it, and another feature is so just launching the KVM from here, from within our GUI, so which all Bright cluster admins will be using this GUI most of the time.
So you can basically, you can do pretty much a lot of the same things you can do in the SIMC UI right from your Bright Cluster Manager.
Exactly. That was the main goal. So just try to make it as at least the user interface part, at least as similar to the SIMC UI for people who are used to the SIMC UI, and that's why we have actually kind of made these groupings just similar to what you would see in the SIMC UI.
And those are editable. So if I would want to change the
so if you look here, so for example, all these settings come directly based on a translation mechanism from the XML schema or rack-in schema. So basically, you'll see all the valid entries here are automatically populated.
And then if you wanted to override that, you could set that, and then it would send that configuration back to the C-Series server.
Yeah. So if I just say let's say I just set this to platform default. It's not changing. try another node. Okay, there's something. So basically what you do is just change it here, and then this save should highlight, and then it just saves it and sends it back to the SIMC. So it just translates this into an XML, into the XML, and sends it to the SIMC.
And so then that would allow you to be able to fully configure your C-Series server right from here. And then if you needed to change it, you would, again, you could basically manage, you know, tens or hundreds of systems that are in your particular cluster right from one user interface.
Exactly. So yeah. So basically, so this is on a per node basis. So if you look at the categories, so basically all these nodes belong to a category in a Bright cluster. So basically, so there is nothing configured for the category yet. But if you had configured the category configured all these BIOS tokens for the category, then you would just basically hit save here, and then it will be applied to all the nodes in the cluster.
Oh, so it's almost kind of like, you know, a policy-driven management where you could set it in one place and then it will filter down to all of the child nodes or the nodes that it would, you know, under this particular cluster.
Yeah. So typically, since for the rack servers, we don't interact with the UCS manager. So this probably would conflict with what you would be setting as a service profile for each of the servers. So we still have to decide on how the interface would be in that case. But for standalone rack servers, this would be the interface.
No, this is great. So you said you have some future plans to do integration with UCS Manager and such, but the first step into managing UCS servers was with the standalone rack mounts.
Yeah, exactly. So actually, the next step is actually starting to interact with the UCS Manager and try to manage the blade servers, blade chassis.
Now, this has been great. I think this is a good view of what is possible, what can be done with a solution. I mean, we've given a couple examples, one with Bright and one with the Cisco UCS Management Homebrew project that Jeff was showing, both using the same interface and getting a lot of the same data, but for two totally different use cases. I want to thank you, Johnny, for joining the call. I think this is, it's been a short demo, but very powerful in what can be done with Bright Cluster Manager in an HPC environment. So I want to wrap up here. I want to again thank the panelists. Thanks Jeff. Thank Johnny, Steve, for everyone that also for everyone that had joined and watched this live, as well as anyone that may join this and watch the recorded version of it. I want to recommend people to go to our UCS Communities website again. That's communities.cisco.com/UCS. That's a great place for you to learn. We post all of the tech talks here, as well as announce any new tech talks that are coming in the future, as well as for those who want to get information about our integrations, like our Microsoft System Center integrations, UCS Power Tool. You can go to the UCS Integrations community site, and again, that's communities.cisco.com/UCS Integrations. And one big shout out that I want to make is on communities, it's where you can get our XML Programmers guide. Everything that we show today, from the Pi to the Pi was our code name for the management solution that Jeff was talking about. For everything from the integrations that we're doing with Bright, as well as our Homebrew project to Power Tool, it all has leveraged our XML Programmers guide. So if you want to write your own code and don't want to leverage our SDKs, that has tons of examples on how to do integrations, as well as it's where you can get the utilities that Jeff and Steve were showing for managing your C-Series servers. Again, I want to thank the panelists, and hope you guys will join us in January in the new year when we have our upcoming UCS Tech Talk. Watch out for communities on the date and time of when that will, and the topic of what that will be. So again, I want to thank everyone, and we'll close this out.